Hello and welcome into the example video for lesson 15 for Precalculus 2. In this video, we're going to be looking at examples of converting complex numbers to polar numbers, multiplying polar numbers, dividing polar numbers, etc. Here, the document camera here. If you hear thrashing in the background, that's Daisy scratching her back, I guess. Doing, cutie? All right. So let me start by saying, so the first types of problems we're going to look at is to write the complex number in polar form. So I'm going to do 3 of these. These conversions are the most important part of this lesson. If we cannot convert these, if we cannot find the modulus, if we cannot find theta, then we can't do anything else. Because if I have the wrong modulus, if I have the wrong theta, and I try to do multiplication, if I try to do division, if I try to use de Moivre's theorem, it's not going to work out for me because it's like the saying goes, garbage in, garbage out. So if my theta is supposed to be pi over 4 and I'm using 3 pi over 4, I have no chance of getting it right. So we have to be so careful in this stage of the process, these conversions. So the first one is I have -1 minus root 3i. So before I begin this, I'm going to ask myself, which quadrant am I in? And my what? My A is negative, my B is negative. So I'm down here in quadrant 3. Excuse me, sorry about this cough. It just won't go away. So when I calculate these, my theta better be in quadrant 3, or it's wrong right off the bat. So the first thing, I need my modulus, my Z, which is, well, my R, which is the modulus. So it is the square root of -1 squared plus negative square root of 3 squared, which is the square root. -1 squared is 1 plus negative root 3 squared. Negative times negative is positive. Square root of 3 times square root of 3 is 3. So this is square root of 4. This is 2 for my R. Then I have tangent of theta is B over A, which is negative root 3 over -1. Negative divided by negative is positive. So square root of 3. Daisy, hey, stop. So then I'm asking myself, where in quadrant 3 is tangent equal to square root of 3? Well, from our first quadrant, we know what? We know that pi over 3 is root 3. So I want the radian measure in quadrant 3 that has 3 in the denominator. So that's going to be what? That's 4 pi over 3. I've been teaching this class way too long to where people think, okay, I got the answer. Let me put it in the format and I'm good to go. Okay, so let's do that. So we have Z is equal to R to cosine of 4 pi over 3 plus I sine of theta, 4 pi over 3. But this is a question on a test, and I can't afford to lose any more points if I really want to get the A in this class. So how can I figure out if this is correct or not? Well, the answer is just convert it back to a complex number. convert it. And if I don't get this as my answer, I know I've done it wrong. So let me check. Cosine of 4 pi over 3 is what? It's negative half. Plus I, well, what's sine of 4 pi over 3? That's negative root 3 over 2. So now I'll multiply both of these by 2, and I get what? Negative 1 minus, the 2's cancel out, square root of 3i, which is what I started with. So now I am 100% sure. I'm going to turn this in, and on my way out the door, say, George, you don't even need to grade the complex to polar problems because I checked my answer and it works. So I know I have all of them right. And it would make me so happy to have that be the case, that I can just zip right through your test and like, yep, they checked their answers, they know what's right, give them all their points. Second one, 5 minus 5i. So I'm going to pause for a second, let you hit pause if you want, try it, see if you get the right answer, check your answer, see if it comes out right. But if you're not quite sure, you can just let it keep playing. We'll work through this. And like I said, there's one more. And then on the third one, I would highly recommend you try doing it yourself. Because you, as I said, you have to be able to do these types of problems. You have to be able to do these conversions. So, as always, which quadrant am I in? Well, A is positive, B is negative, so that's quadrant 4. So my theta better be from quadrant 4. So first I need my R, which is square root of 5 squared plus negative 5 squared, which is square root of 25 plus 25, which is square root of 50. And this is like 25 times 2. So I can convert this to 5 root 2. And you should be able to do that. You're going to need to simplify your answers completely. Also, when we get to our multiplication division, you're going to want your theta to be between 0 and 2 pi. We'll deal with that when we get there. But you should be able to simplify a radical into 5 root 2. Simplify your answers. Now we need our theta. So tangent of theta is b, negative 5, over a, positive 5, which is negative 1. So where in quadrant 4 is tangent negative 1? That's when theta is 7 pi over 4. So my complex number in polar form is z is equal to 5 root 2 cosine 7 pi over 4 plus I sine of 7 pi over 4. Third one, and as I said, my recommendation is when I give you this, hit pause, try to work it yourself and make sure you can do these. So you have negative 3 root 3 plus 3i. So go ahead and hit pause. I'm going to hold on here for a second, work it out, come on back, see if you got the right answer. All right, I'm assuming you checked your answer, so you already know it's right, but let's work it through anyways. What quadrant are we in? Negative, positive, that's quadrant 2. So my R is square root of negative 3 root 3 squared plus 3 squared. So that's square root of 9 times 3, which is 27, plus 3 squared is 9. So that's square root of 36, which is 6. Tangent of theta is b, 3 over negative 3 root 3. The 3's cancel out. I get negative 1 over root 3, which if I rationalize it so it looks what I'm familiar with, I get negative root 3 over 3. Well, that's like my pi over 6, but I'm in quadrant 2. So what value of theta in quadrant 2 has 6 in the denominator? That's theta is 5 pi over 6. So this complex number written in polar form is 6 times cosine of 5 pi over 6 plus I sine of 5 pi over 6. All right. Now, the type of problem you're going to see on an exam. So given Z1 is root 2 plus root 2I, and Z2 is negative 1 plus I, find the following. Find Z1 in polar form. Z2 in polar form. Find Z1 times Z2. Z1 divided by Z2. And 1 over Z1. And for all of these, theta has to be between 0 and 2 pi. So don't give me an answer like theta is equal to 19 pi over 4. It's not between 0 and 2 pi. Find that value on the unit circle. All right, so first, Z1. I need my R1, which is the square root of root 2 squared plus root 2 squared, which is the square root of 2 plus 2, which is the square root of 4, which is 2. Then tangent of theta 1. Oh, so I should do the quadrants, right? So Z1, positive, positive, so that's quadrant 1. Z2, negative, positive, so that's quadrant 2. So tangent of theta 1 is root 2 over root 2, which is 1. And in quadrant 1, tangent is equal to 1 at pi over 4. So Z1 in polar form is equal to 2 times cosine of pi over 4 plus I sine of pi over 4. For Z2, I need R2, which is the square root of negative 1 squared plus 1 squared, which is the square root of 1 plus 1, which is square root of 2. And tangent of theta 2 is 1 over negative 1, which is negative 1. So where in quadrant 2, let's move that down, where in quadrant 2 is tangent equal to negative 1? Well, that's when theta, or in this case, theta 2, is equal to 3 pi over 4. So that means Z2 is square root of 2 times cosine 3 pi over 4 plus I sine 3 pi over 4. Now we need Z1 times Z2. Let me see if I can. All right, let me fold this in half here. See if I can sort of keep it all on one screenshot for you guys as we're working it. Let's see. Is that going to work? Let me zoom out a little bit so I can try to get this all in one, but I also want you to be able to see it. Well, you know what? Let me do this. Let me just transfer it to this page. All right, so we have Z1 is 2 cosine pi over 4 plus I sine pi over 4. And z2 is square root of 2 cosine of 3 pi over 4 plus I sine 3 pi over 4. All right. So next we want z1 times z2. So by the formula, that's just multiplying the r's. So r1 times r2. And then cosine, we have to add the thetas. Pi over 4 plus 3 pi over 4 plus I sine pi over 4 plus 3 pi over 4. So we get 2 root 2. Pi over 4 plus 3 pi over 4 is 4 pi over 4, which is just cosine of pi. Plus I sine, and it better be the same thing. So plus I sine of pi. z1 divided by z2. So this is r1, which is 2, divided by root 2. But now we have to subtract our thetas. So pi over 4 minus 3 pi over 4 plus I sine pi over 4 minus 3 pi over 4. So this one, I can rationalize it. So if I have 2 over root 2, multiply the top and bottom by root 2, I get 2 root 2 over 2. And the 2's cancel out, so I just get square root of 2 in front. And then cosine pi over 4, so 1 pi over 4 minus 3 pi over 4 is minus 2 pi over 4, which if I divide by 2 is minus pi over 2 plus I sine of minus pi over 2. Now, sorry. Okay. But the problem said what? Theta must be between 0 and 2 pi. Negative pi over 2 is not between 0 and 2 pi. So I have two options. Option 1, find where on the unit circle do I have negative pi over 2 and then substitute that value in, which would be what? 3 pi over 2. Or the other option is to do what? Use our even odd function property with sine and cosine. So I get root 2 in front. Cosine is an even function. So what happens with an even function? The minus sign goes away. So this is the same thing as cosine of pi over 2. But sine is an odd function. What happens with odd functions? Well, the minus sign comes in front. So this becomes minus I sine of pi over 2. So that is your answer for z1 divided by z2. Here was your answer for the product. So we just used our even odd property. Cosine negative value, sine goes away. Sine of a negative value, this negative sign moves in front. And then we have 1 over z1. So how do we do this kind of problem? Well, think back to your probably first day or second day of Math 126 when you were doing exponents. This is really the same as what? 1 over z1 to the first power. So if I take this from the denominator to the numerator, this becomes what? z1 to the minus 1 power. And now I have what? An integer exponent. So I can use de Moivre's theorem, right? In de Moivre's theorem, so now my n is equal to -1. So z1 to the -1 power, which is what I'm calculating, is r to the -1 power cosine of -1 times theta plus I sine of -1 times theta. So for z1, my r was 2. So I have 2 to the -1 power. And then cosine, well, my theta so I should put theta 1 here, r1, theta 1, theta 1. So theta 1 was pi over 4. So this is negative pi over 4 plus I sine of negative pi over 4. And now we're going to do the same thing we just did up above, right? So first of all, 2 to the -1 power is 1/2. The 2 just goes in the denominator, so the exponent becomes positive, kind of the reverse of what we did up here. And now the minus sign goes away, so cosine of pi over 4. Here the minus sign moves in front, so minus sine pi over 4. So you can see that's a pretty lengthy problem and a lot of places where you can mess these up, mess up a sign, mess up addition, subtraction. So be careful, especially calculating your R's and your thetas. Because if way back here, when I calculated these R1 and theta 1, if any of these, if this was wrong, if this was wrong, if this was wrong, if then that means this is wrong, and this, and this, and this, and this. And so now all of a sudden, a 10-point problem, you get like 2 points because you had R1 and R2 correct, but everything else was wrong. So how can I give you any credit for anything? Because again, you were using bad information the whole time. I'll probably give you some credit as long as you like used your wrong numbers correctly. You probably will get some points, but don't even leave it up to that. Just go ahead and do it right from the get-go. All right, last problem for this video is using de Moivre's theorem again, but a little more straightforward on a problem. So use de Moivre's theorem to find √3 minus I to the 6th power. And now be careful here. So write your answer in A plus BI form. So do not leave it in polar form. Do not leave your answer looking like this. What you'll have to figure out, what is cosine of pi over 4? Multiply it by a half. What is sine of pi over 4? Multiply it by a half. That'll convert it back to A plus BI form. So for this one, first off, my n is what? My n is 6. And then I need my r, which is the square root of √3 squared plus -1 squared, which is the square root of 3 plus 1, square root of 4, which is 2. And again, I should have started, sorry. Which quadrant am I in? Positive, negative, quadrant 4. So my tangent of theta is b -1 over a √3, which is -√3 over 3. That's like pi over 6. So where in quadrant 4, what value has pi over 6? That's 11 pi over 6. So now, write it out in polar form. So z to the 6th power is my r, 2 to the nth power, 6, times cosine of n, which is 6, times theta, 11 pi over 6, plus I sine of 6 times 11 pi over 6. So now simplify. 2 to the 6th power, that's 64. 6 times 11 pi over 6, well, the 6 cancels out. So I get cosine of 11 pi plus I sine, and I'm going to get the same answer, I better, 11 pi. But that's polar form. We don't want it in polar form, so I need to convert it. So what is cosine of 11 pi? Well, 11 pi is where? It's on the left side of the unit circle. So cosine at that point is what? It's -1. Plus, what's sine of 11 pi? Again, I'm on the left side, but sine of any odd pi value is 0. So 0i. So it's just what? Multiply this. 64 times -1 is -64 plus 0. So your answer is just -64. So that's how you go from polar form here to a plus bi form. And it's like, wait, no, there's no I. Well, yeah, in this case, the I kind of disappeared because of that 0. But if it's given on a test or given in the homework, write your answer in a plus bi form. That's what you need to do. Use your unit circle, figure this out. Use your unit circle, figure this out, convert it. So that's it. That is the examples for lesson 15. Come on back and we'll take a look at the content for lesson 16.